So refraction. Refraction is, as if you haven't watched the reflection one, the idea is that all waves, remember, can be reflected and refracted. But when we talked about the details of refraction, we usually talk about it with a light wave, right? And refraction is what happens when when a wave leaves one medium and enters another. So basically, it's when a wave changes medium. And what you want to think about, so usually this is done when we're talking about going from air to plastic or glass or water, and all of those things, of course, are going to be more dense than air. And so what I've got here is I've drawn a fake glass block, in case you can't tell that's not real. And so we have a light wave that is coming in. Now, what happens when a wave changes medium is that one thing always happens. Usually two things happen, all right? The idea is it changes speed and it changes direction. All right, now it always changes speed. All right, it's entering a new medium. If that medium is more dense, of course, it's going to slow down. If it's less dense, it's going to speed up. All right, so it always changes speed, but it usually changes direction as well. There's an exception to that, then I'll talk about it in just a minute. All right, so if we have our light wave that's coming in here at an angle, okay, and this is the air here. So it comes in and it hits the glass block. Now, glass isn't reflective, so it's not going to be reflective off. Instead, it's going to pass into the glass block. So we start the same way. We draw our imaginary line that is perpendicular to the surface. So this is our normal, okay? And then we still have an angle of incidence here. This is our angle of incidence. And that is often abbreviated with just the lowercase letter I. Okay, so that's our angle of incidence between the light wave and the normal. And then what's going to happen is that it's going to come out the other side, but it doesn't come out evenly. Because it changes speed, it's also going to change direction. So this is called the angle, that should be a straight line. Let's pretend it is, the angle of refraction, and that is often abbreviated with just the letter R, right? But the idea is that because the wave is moving faster in the air than it is in the block, when it goes from, so this is less dense medium, when it moves from less dense to more dense, which would be the glass, then when you're going in that direction, the light wave is going to bend towards the normal. All right, so the idea is that the angle of refraction is actually going to be smaller than the angle of incidence in this case. All right, so then it travels through the block. Let's see if I can try to do this straight. Oh, not very well. Right, and then it hits the outside of the block. Now, so again, I draw my normal here. Now, this angle is my angle of incidence, so that's I. You see that? All right, and now it's going from a more dense medium to a less dense, right? Back out into the air. And what happens with that? And so then, oops, sorry, lost. Anyway, yeah, more dense to less dense. And so then it's going to bend away from the normal. And this is now your angle of refraction, your R. And so when it goes from more dense to less dense, then the wave is going to bend. It picks up speed. It starts going faster, so it bends away from the normal. Right? This whole thing, by the way, is called a ray diagram. If you're ever asked to draw a ray diagram, that's what this is. All right. So the idea is that it bends, it shifts slightly. And of course, you've seen this if you've ever looked at anything that's in water that's above and below the surface. It looks like the straw or whatever it is broken, right? And so the idea is that you get this shift towards the normal, bending towards the normal, and then bending away from the normal as it goes from either less to more or more to less. Now, I said that it always changes speed and usually it changes direction. So here it's changing direction. The only time it doesn't change direction is if you have a light wave that is coming in and it is along the normal, so it is already perpendicular to the surface, the idea is that the light wave will enter and it will not change path if it is already at a 90-degree angle. If the angle of incidence is already 0, then the angle of refraction will also be 0. And so it still changes speed here, but it's not actually going to change direction. So that's the exception to this idea of changing speed and direction. Usually it changes direction, but sometimes it doesn't. Now, there's a mathematical relationship for this, okay? So the idea is that you have your angle of incidence and your angle of refraction. And so we say there's something called the refractive index. And the refractive index is basically how dense is a medium. So the refractive index, and it is abbreviated N, you can remember that like index, all right, N, is basically a measure of the density. And we set, so not we, I didn't have anything to do with it, but whoever discovered this stuff, basically the refractive index of air here on Earth is 1. So anything that you are dealing with, glass, plastic, water, will always have a refractive index of more than 1. If you get something that's less than 1, you've done something wrong, all right? And you can determine the refractive index by looking at the sine, which is a trigonometrical function. Those of you in EC2, you should be familiar with this. Those of you in EC1, we've worked on it a lot. Some of you have taken me at my word that it's a button you need to press on your calculator. Others of you have asked for more explanation, and I'm happy to give that outside of this video. So the sine of the angle of incidence divided by the sine of the angle of refraction. So this is your equation that you need to know. And so they could give you any two of these values, right? They could give you the refractive index of, say, glass plus the angle of incidence and then ask you to find the angle of refraction. Or they could give you the two angles and ask you to determine the refractive index, things like that. So that is refraction. And that's the equation that you need for it.